Alright, let's look at the homework 3.3, problem number 7. Right, so we have the graph of f prime, right, just like the one we did before. Right, so on what interval is f increasing? So we are looking for the place where the function is above the x-axis. Right, so you can see that it's from 0 to 2, right? From let's see, 0 to 2, right, and here, and also 4 to 6. Let's say derivative of a continuous function. All right, so it's going to be a 4 to 6 and 6. 4 to 6. All right, and then after that it's probably a to, let's see, that continues to infinity. Assume that that continues to infinity. All right, so a to infinity. All right, so take the union. All right, a to infinity. All right, so we got that. Oops, infinity. All right, it's decreasing, so it's going to be between 2 and 4. All right. Right, and also here between 6 and 8. All right, we have that. And at what value of x does x have a local maximum? All right, so local max and the local minimum. So we have to have both. All right, so local max. So we're going to have to look for the critical numbers. All right, critical numbers are either derivative is 0 or derivative is actually undefined here and a derivative is 0. Right, so look at this guy. Right, so derivative positive to negative, so increasing to decreasing, so we know that that's going to be a local maximum. So at 2 it's a local maximum. Right, at 4 you can see that the derivative is negative to positive, which means that the decreasing into increasing, so it's a local minimum. So at 4 it's a local minimum. Right, and here 6 is a tricky one, but you can see that it's an increasing actually turn into decreasing because it's below the x-axis. So increasing to decreasing, so that's actually give you a maximum. So local maximum at 6. All right, then at 8, so it's a negative to positive, so decreasing to increasing, so that's going to be a minimum. So at 8. Oops. Over here at 8. All right, on what interval is f concave upward? Right, so we are looking for, so we want the derivative to increase, so you can see that it's from here, let's see, so 3 to 6. All right, and also 6 to infinity. 6 to infinity. All right, and for concave downward, so it's decreasing here. So it's a 0 to 3, and that's it. Okay. 0 to 3. Oop, yep. All right, concave downward. And what are the x-coordinates of the inflection points? All right, so you can see that from 0 to 3 and 3 to 6, concavity changes at 3, right? And at 6, concavity really doesn't change, so it's going to be 3. It's the only one, right? And you don't have to worry about this one. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got part A correctly and part B correctly and part C correctly and part D correctly. All right, that's it. I hope that this was clear.